reminds me how many industries we work in at Nvidia. And for us, that's just more data points to share with you. One that I want to call out, because people sometimes ask me, why does Nvidia spend so much time in autonomous driving vehicles? Well, we spend so much time there because we're learning so much of what you can do to really put a car on the road. And one data point I like to share with everybody is, to put a car on the road, the amount of predictive analytics that you have to be doing nonstop is really incredible. There's not just one model or one application that's allowing a car to go down the road like that. There's about 10 different ones talking to each other nonstop, all relying on information about where you are, where's everything around you, and how's it going to interact, and what are all the different possibilities, what are all the different patterns that could be going on. So when you need to make the decision in a completely level 4 car or level 3 or level 2 car, it's going to know how to do it. All right. So, and we could go across industry to industry to industry, talk about all these different things that happen. And I want to leave one thing with you, and we'll then jump right back into your industry, is look outside. Because the technology that we're developing in AI, the technologies that's solving a lot of the data problems that are out there, is very horizontal. It's your data, it's your domain expertise that makes it vertical. So there's solutions that are being solved in distribution by the likes of Amazon. There's solutions that are being solved at airports. There's things that are being done in so many different ways that can be leveraged. Because what we deliver is horizontal. And why are we able to do this in such a horizontal way? Well, there's this little thing called the rise of GPU computing. Most of us, especially if you look like me, have ridden our career in the technology industry based on Moore's Law. Year after year after year, we saw an increase in compute power, and we were able to benefit from it. And we had some really smart computer scientists who were able to take what is really a serial process and make it parallel as much as possible by leveraging that compute power. But now, that has pretty much hit the semiconductor laws of physics. So what used to be 50% is now 10%. So one of the things that I'd like to challenge everybody to think about as you're going through this transformation and all the focus on data and what needs to happen, and shift happens, because shift is about to happen pretty aggressively, what are you going to do? And are you going to rely upon 10% performance gains over the next couple of years to get you there? And most people realize that's not going to get you there, and for a number of reasons. That just because you can't process the data, you can't have applications run fast enough. And that's going to be the challenge that most of us need to overcome. And that's where the shift here from GPU computing allows us to do. We take what is parallel, what is data-centric, and we move it to the GPU, and amazing things happen. All right. So, real quick, 101, deep learning, and then we'll jump into some other stuff. There's two aspects to it. People usually say, well, what do we need all this compute power to? Well, there's this idea of training. You take as much data as possible, and it's really a new way of writing software. Think about it that. Data is your new source code. You're no longer trying to figure out what the features are and have it coded all exactly, and then to do some QA and then ship software. You're letting data drive what you're trying to do. And then once you create that model, we infer. We take it into deployment, and we do inference. And more, these are actually becoming interchangeable because data is so important that a lot of times I build models that are inferring on the data that help me decide what to train on. So this is really becoming an end-to-end solution that we have to think about and how we're going to solve, but is really, really driving some incredible solutions like we saw in the beginning. And these advances are happening so fast. From starting 2012, when Alex Krizhevsky destroyed what everybody thought was ImageNet and how we could do hand-coded machine learning, every year we're seeing gains. He beat it in 2012 and pretty much established deep learning and AI is going to be better than this hand-coded approach to doing it. But every year, the models get deeper, the insights get better, and these are the things that you can be leveraging. So it's not standing still, it's actually moving quite quick. So, you guys know by now the value of GPUs have played in, seismic prediction, what's the futures of oil production going to happen, and the deep compute power that needs to be there. But today we're not going to be spending a lot of time on that. I want to spend more now on time how that same platform, that same compute capability that allows us to research and see different things we couldn't see before can be applied to the rest of the world, to the rest of your business. Now, the good news is, in order to get to a point where you want to have limited capabilities of I was trying to process data and I couldn't, we can get beyond that. And you want to get to a point where you can have predictability. And predictability really comes from, how do I say no more unplanned downtimes, right? Data is essential for that predictability. Data is the only way that you're going to get there. And what we've done in the past is we've treated data as a problem. And if that sounds odd to you, think about it. Terms like data deluge. Think about the fact that how many times you've gone to a data scientist or your business analyst and said, how are you going to go about doing that? Well, I said, well, I'm going to come up with a solution that is directionally correct or statistically correct because I'm able to take a sample of the data. A sample of the data, or I'm going to pre-aggregate some of the data and I'm going to run my models on that. Basically what that's saying is we've limited the guys whose job is to process the data to give insight with technology. And when you limit them, they come up with workarounds. So now, when you think about what's going on in the world, when you think about aging populations, aging, what's going on from aging equipment, all this stuff happening, now you need data, you need the predictability, and we need to give the data scientists, the business analysts, the tools that allow them to process that data. And yes, be able to secure the data. I love the discussion on cybersecurity and how that will happen as well. So, let's take one example of how this is happening. If we think about offshore operators and the cost of downtime, unplanned downtime, let's say on average it's about $50 million a year, right? It seems very reasonable that if we went through a digital transformation and we leverage this data, we should be able to see 30, 35, 36% performance gain on that. We should reduce those costs. We should be able to save $18 million. I think that sounds reasonable. But we haven't been able to because we've limited the people that we've tasked this with technology that forces them to do sampling, right? So let's now take a different view of that. Let's look at what GE is able to accomplish, because who has better knowledge about how machines work than GE, right? So they look at this stuff, and if you can see the chart there, those blue lines are indicating of the intelligence they have about the machines, the predictability of those machines. That's what they were able to accomplish. But enter AI, enter deep learning into the equation, and now you can get 20% increase. 20% increase. So if we go back to the 50 million, 20%, that's $10 million. Just because you can get 20% increase. Now, if we keep applying it to different aspects of it, the cost savings will keep coming over and over. So, how are we going to get them to come over and over? Well, this isn't just a one-off solution. This isn't where we think about, okay, how am I going to do just this task? Again, it's very horizontal in nature. It's how you apply it that makes it vertical or more workflow targeted. So what we're doing here is we're taking several workflows across an end-to-end architecture and thinking about how we go through the process step by step. So remember when I said you can do training, that's what we have here in the data center. But as the data comes in from the field, I want to be inferring on that. I actually want to do compute where I can. I want to take compute and the processing that data out to the edge. So as the data is coming in, I can be classifying that data, doing components with that data, and then matching that with my historical data, taking it to the data center, training new models or retraining models, and then I can take that out to a SaaS-based application so people can access it, right? The idea is not just to create these wonderful pieces of information and limit it. Put it on a SaaS model, put it out in the cloud so that we can do inferencing. We can determine, what's the life of that going to be? How long is that going to live? How long can we benefit from that? What's the projected uptime of that? So all these things become an end-to-end workflow, and that's what you have to think about. It's one architecture across all this. You develop something in the data center, it'll run on something that's about the size of this, about the size of a credit card, which 5, 10 years ago we would have considered a supercomputer capable, right? That's our Jetson. It goes in drones, it goes into all kind of sensor devices. It sits next to your sensors to help you process data. It looks at it from all the different angles you could talk about. That is really what's going on that's changing a lot of the process. So, I've been telling you a lot about the compute capability, that it's radically changed and it's advancing so much faster. But really, one of the key enablers here is the software. Nvidia spends a lot of time pulling together all the software, optimizing it, containerizing it so that it can be readily used in a DevOps model or however it fits into your environment. And you can see the gains we're getting. 50x training setup. We're getting 10 times faster ability to explore your data, right? And then when you can go all this and we're saying, what's our goal? Well, let's reduce failure. Let's have faster failure detection. Let's go through that process. Speeding that up is one way of looking at, we're saying, how do we do non-productive time? This is increasing productive time, right? So they both save you a lot of time. This platform, this software that we're talking about, Baker Hughes GE puts on top of that their applied AI. So again, these workflows take advantage of it. And again, it's a repeatable process you can go through. One of the components here is this simplified AI at scale. And that's one of the things I have to have everybody grasp. This is not your data center approach of 10 years ago. This is not your data center approach of 5 years ago. And everyone says, well, what do you mean by that? Well, let me show you one of the core components that are going into this. This is the latest AI supercomputer that we launched a few months ago that's going to start shipping very soon. We flipped what compute is on its head. And we've been doing this for several years now. This has 16 GPUs inside of it, all that act as one. So it's essentially the largest GPU ever shipped. We do that by putting switches right on it, and they can communicate and do processing there. It's the world's first 2 petaflop system. It's amazing compute power. Even when people see this, they say, okay, great, but really to tackle these problems, I need data centers, I need to figure things out, because this is the mentality we still have. This is from an IT standpoint. We think, oh, I need so much compute power, I'm going to need a row of servers. Because what I need you to grasp is this row of servers, with the amount of power that it's drawing, with the amount of cost that it would take, with just the interconnects alone on this is about $500,000 to $1 million, if you think about it from that standpoint. But at 180 kilowatts, the amount of concrete I need, the amount of data center space I need, it becomes daunting to the IT team. How can we do this? Well, it's because they haven't made the shift. The equivalent, showing the machine I just showed you, is this. I don't need a row to bring you that level of compute. I need a rack. And if I put several of these in a rack, I've just saved you several rows. So not only are we looking at this, how do we save you time on the non-productive resource allocations that you have to go through, or the non-productive things that are going on downtime over your equipment, save you time in the data center, save you money in the data center is a big focus. So when we look across everything and we try to figure out how does this apply to many different areas in your business, we look at it across the entire value chain. And we could call it the full stream of everything you're doing. There's repeatable workflows that help you to harness the data, explore the analysis of that data, build new models, deploy new models at the edge, and have this be interactive end to end. Again, that example that I gave you for auto is a reason. When you have different models and applications talking to each other to bring together an overall solution that is essential to protecting us, that is essential to relieving a lot of the traffic things to do, think of how those as a series of microservices can come together end to end, full stream, and solve your business problems. Think outside how you've been addressing it today, and think about how you could address it if you started treating problems like data as solutions like data. If you started thinking as data being that source code instead of that deluge that we're dealing with. This allows us to rethink a lot of things we're doing, and right down the list you could come up with ideas of how that could happen. So, as you guys think about how to make your equipment more productive, how do you have less downtime, I always think day in, day out, how do I make data scientists more productive? Think about it. What an incredible resource we all have at our disposal, or that we're leveraging to solve these problems, and we give them tools like a notebook. If I was a data scientist today and I walked into a new job and someone handed me a notebook, no disrespect to the notebook manufacturers in the world, That's great for doing my email. That's not great for developing the models that are going to solve your problem. They need access to the tools that really allow them to do their great work. And that's one of the things that we're happy to help you with that. But the other side of it is we know there's a cultural shift. And I've seen several presentations where you guys have talked about cultural shifts and how things need to change and how to go through the process. So we offer something called the Deep Learning Institute, which helps business leaders as well as technical leaders figure out what the next step is. How do they go through that process? The best thing about this Deep Learning Institute is it's online. It can be self-paced. Or as companies get further along in the process, what they usually like to do is bring it in, do it in-house, and then turn it into a workshop to figure out how we're going to help you take all the data that you've been collecting, how all this big data that's been sitting around unproductive, how we're going to take that 95% of that data that you wish you've been using but aren't, and make it productive. That's where the Deep Learning Institute to a workshop can pay off and do great things for you. And then all the stuff that I talked to you about, the software that we have, we make it freely accessible. We encourage people to experiment. Download our software, go to the Nvidia GPU cloud, log in, sign in, and access the software you need to develop the models you want. Not only do we do that, we help those who are doing it publish their research, make it widely available from all these different industries so that you can go and say, hey, wow, did you see the example they're doing here? How's that any different from what we're doing? And take advantage of it and really build on top of that. So with that, I'd like to thank you. I hope that you are having a great show. And I want you to remember that we're here to support you. We have a great relationship